Welcome to the HT8 MCU Basic Tutorial. In this session, we will be exploring Comprehensive Experiment 4, External Interrupt Wake Up. This experiment will introduce this function from 5 aspects. External Interrupt Wake Up Experiment Introduction. Hardware connections. Program development. Practice results. And experiment summary. External Interrupt Wake Up Experiment Introduction. This experiment has 2 learning objectives: to use an external interrupt to wake up the MCU, and to master the timer counter mode of the timer module. Now, let's look at the experiment content. The timer counter mode of the timer module is used to drive the digital tube in a time-sharing manner and update it regularly. After powered on, the MCU controls the digital tube to display the digits 0 to 9 sequentially at 280 millisecond intervals. After this, it enters the sleep mode. When a key is pressed, the external interrupt pin detects a falling edge, triggering an external interrupt to wake up the MCU. After the MCU has been woken up, it controls the digital tube to display the digits 0 to 9 sequentially at 280 milliseconds intervals. After this, it enters the sleep mode again. In this experiment, in addition to the wake-up function, the timer, GPIO, internal oscillator, and watchdog function are also used. Then, let's look at the components required by this experiment. The experiment uses the DEV3195 development board as the main control board, and uses the emulator to provide a 5-volt power supply voltage. The following components are also required: a digital tube, a key, a resistor, a breadboard, a Type-C line, and some connection wires. Hardware connections. Next is the schematic diagram for this experiment. The DEV3195 board used the HT66V3195 as its main control MCU on. There is a bypass capacitor between the power and ground on the board, which can stabilize the power supply voltage and filter out AC noise. As the MCU GPIO supports the internal pull-high function, the key connected to a GPIO pin is configured as an input with input pull-high enabled. A common anode digital tube is used to display the digits 0 to 9. This experiment uses a breadboard. The connection diagram is shown here. The E-Link Pro 2 provides a power supply voltage of approximately 5 volts. The programming pins are located above the development board. These can be used for emulation or programming with either the E-Link Pro 2 or the eWriter Pro 2. The following is the breadboard wiring physical diagram, for your reference. Program development. Let's look at the main function flow of the MCU, which includes the system clock configuration, watchdog configuration, digital tube I/O configuration and initialization, external interrupt configuration, timer configuration, enable global interrupt, clear watchdog, digital tube display, enter sleep mode, wake up restore working mode. The following is the timer interrupt function flow. When the MCU has been woken up, the timer is enabled. The MCU will enter the timer interrupt every 2 milliseconds. When using the timer counter function and comparator match function, the interrupt request flag STMAF should be determined when entering the interrupt. During the timer interrupt, the counter value increments and the display flag is set high. The display content of the digital tube will be updated when the counter value reaches 140, that is, timing 280 milliseconds. Next, let's look at the program example. This is the main.c file. This experiment includes the HT66F3195.h header file, which defines and declares the registers, ports, peripherals, etc. of the HT66F3195 and HT66V3195 MCUs, facilitating program development. Before writing the program, it is regular to define the pins to be used via macro definition, which facilitates program development. These include macro definition for the digital tube pins, output configuration for these pins, and the commands to set these pins to output a low level or high level. The following is the display encoding table for the common anode digital tube. The MCU uses the lookup table to control the digital tube I/O ports to display the corresponding digits. Using the struct and union together makes the program clearer and more efficient. The following defines a struct and a union for storing digital tube display data. Function declaration informs the compiler of function names, return value types and parameter list, thereby resolving compilation errors caused by the function being defined after it is called. Variable declaration and definition creates variables, informing the compiler of the variable names and data types, and assigning memory for them. Next is the main function. First, initialize the variables. Then, configure the system clock, the watchdog, the digital tube I/O ports, the external interrupt and the timer, and enable the global interrupt. In the main loop, first clear the watchdog timer and sequentially display the digits from 0 to 9. After this, enter the sleep mode again and wait for next wake-up signal, where the digital tube display uses a time-sharing manner to drive the SEG, switching the SEG every 2 milliseconds. Next, we will introduce the different parts of the main function. The following is the system clock configuration function. Here, the system clock uses the internal oscillator and selects 8 MHz. Next is the watchdog configuration function. Enable the watchdog and set the watchdog timeout period to 512 milliseconds. If the time exceeds 512 milliseconds, the MCU will reset. Therefore, it is important to clear the watchdog timer during normal operation. Next is the digital tube I/O configuration function. Set the I/O ports of the digital tube to the output mode. Then, control the I/O ports to turn off the digital tube according to the features of the common anode digital tube. As the digital tube is a common anode type, the SEG should be set to a high level to turn off the digital tube. Next is the external interrupt configuration function. Set PA1 pin as the external interrupt INT0 pin and enable this pin pull high function. Select the PA1 pin as the INT0 input source pin, and a falling edge on this pin will trigger an external interrupt. Clear the INT0 interrupt request flag. Next is the timer configuration function. Configure the timer in the timer counter mode, with the timer clock set to the system clock divided by 4. Set the timer counter to be cleared when a compare match occurs from the comparator A. The comparator A match interrupt request flag will be generated when the counter value of the comparator A overflows. The comparator A counter value is set to 4000. As the timer clock frequency is 2 MHz, this corresponds to a timer counting cycle of 2 milliseconds. Clear the multifunction interrupt 0 request flag and enable multifunction interrupt. Clear the comparator A match interrupt request flag and enable comparator A match interrupt. Next is the digital tube display function. Using the time sharing manner for SEGs, only drive one SEG at a time, while the other SEGs output a high level to turn off. The seg-cienta value, ranging from 1 to 7, corresponds to the segments A to G of the digital tube. The other segments output a high level. For example, when seg-cnt is equal to 1, perform an operation on the lookup table data and hex FE, retain the lowest bit of the data as the rest are all ones. It only controls segment A, the other segments output a high level. Next is the enter sleep mode function. Before entering the sleep mode, turn off the digital tube and the LED on the DEV3195 module, pull high any unused GPIO pins internally, disable the watchdog timer and timer, clear the external interrupt request flag and configure HIRC and LIRC to be off when the CPU is off. Then use the halt instruction to let the MCU enter the sleep mode. Note that if the interrupt flag has been set high before entering the sleep mode, the relevant interrupt cannot be used to wake up the MCU. Therefore, it is recommended to clear the interrupt flag again before entering the sleep mode. After the MCU is woken up, the program will continue to execute after the halt instruction. Next is the Wake Up Restore Working Mode function. As the system uses the key wake up function, the key debouncing should be added. If a key is pressed for less than 10 milliseconds, this indicates that an external interrupt has been erroneously triggered due to interference. The MCU will enter the sleep mode again. Conversely, the MCU will restore operation, enabling the watchdog timer, the timer function and the digital tube display. The final is the timer interrupt function. After entering the timer interrupt, the system first detects comparator a match interrupt request flag. The software will clear it to 0 so that it can enter this interrupt next time. The interrupt timing value is 2 milliseconds, the counter value increments each time the interrupt occurs, and the display flag is set high. This process continues until the counter value reaches 140, at which point the display content of the digital tube will be updated. Practice results. After power on, the digital tube sequentially displays the digits 0 to 9. When the display is complete, it will automatically enter the sleep mode. When the key is pressed, the MCU will trigger an interrupt wake up. It then controls the digital tube to display the digits 0 to 9. After the display is complete, the MCU will enter the sleep mode again. Experiment summary. This comprehensive experiment uses multiple peripheral functions of the HT8 MCU, including the following 5. The external interrupt wake up, timer, GPIO, internal oscillator, and the WDT. The hardware part includes the digital tube types and their driving methods. After entering the sleep mode, the MCU can be woken up by an interrupt. Software debouncing is used to prevent external interference from triggering wake-up events. According to the truth table, the MCU sequentially displays the digits 0 to 9 on the digital tube. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.